All right, welcome back for a second semester of Algebra Cafe, and we are starting today chapter 6, which is about systems of equations and inequalities. So the first thing is you want to remember a solution makes an equation true. That's key. So a system of equations is just when we consider more than one equation at one time. So a solution to a system has to satisfy all the equations. For right now, we're going to look at just two equations at one time. Go ahead and take a pause so you can get this written down in your notes. And then we'll start here with understanding what a solution to a system of equations looks like. Here we've got 4, 0, and it's asking, is this a solution to this one equation? This system has two equations. First, we're just asking, is this point, or this ordered pair, a solution to this system? So does it make this equation true? I'm going to put the 4 in the place of the x, which is right here, and I'm going to put the 0 in the place of the y, which is right here, to see if this is actually a solution. So I've got 0 equals 1/2 times 4 minus 2. That is true, so yes, it is a solution. The explanation is that it makes the equation true, which I've shown the work for. Now you're going to check these other points, these other ordered pairs, to see if they are solutions. Letter E says find an ordered pair that is a solution to both equations. In other words, makes this equation true and this one true. And then it says hint, check out the graph to the right. Let's do that. Looking at this graph, we'll notice that 4, 0 is the point right here. 4, 0. That's only on one of the lines. This is only on 1/2 x minus 2. And I notice that -2, 7, which is the other point, is only on this line. What point do you think is going to make both equations true? And you're probably thinking it's this point here, which is on both lines, and you're right. So that point, I'm going to put it in both colors, is 2, -1. Let's try it over here. 2, -1. So first, does it make y equals 1/2 x minus 2 true? And then does it make y equals -2x plus 3 true? It works for both equations, so 2, -1 is a solution to the entire system. So the key information on this page is that a solution to a system of two linear equations makes both equations true and is a point on both lines. In fact, it is the intersection point. So this key understanding is going to help you solve systems of equations in the next parts. On the back here, you will be using these equations to solve a system in context and really make sense of what it means in context. You'll fill out the table, you'll graph here. Then you'll get to the straight practice sheet, and you'll be graphing equations, finding the solution, and checking it algebraically. So let's do one of those together. Here's number 4, y equals x plus 7. So I'm going to find a y-intercept of 7, the slope of 1. My second equation, y equals 2x plus 5. I can see from the graph here, it looks like the solution is 2, 9. I always write the solution as an ordered pair, 2, 9. And then to check, I'm going to check in both equations. So the first equation is y equals x plus 7. The 2, remember, is the x. The y is the 9. Is it true that 9 equals 2 plus 7? Yes. That works. And the second one is y equals 2x plus 5. Again, I put the 9 where the y is and the 2 where the x is. So I know that this solution actually does work for both equations. One little hint here on number 7 is that this equation, you're going to want to probably either find the intercepts or write in y equals mx plus b form. If you need a hint on writing it in y equals mx plus b form, I'll show you that down here. So again, that equation originally was 4x minus y equals -1. So I'm going to try to get the y all by itself by subtracting 4x from both sides. Now this equation, I can go ahead and graph. The other equation, I think you can graph on your own, and you'll again find the point of intersection and show algebraically that it is in fact a solution. Just as a recap, remember the key point here is that when we're finding the solution to a system of linear equations, it will make both the equations true, we can show that algebraically, and it will be a point on both lines or the intersection point.